Okay, so thank you so much. Thank you so much for attending this session. To this session about help, I cannot find out where is the bug. Remember to donate in support of UNICEF. Thank you so much also to all the sponsors that we have that make real this type of events. Remember that about it's very important about the feedback about this event and the speaker. It's I think that providing you feedback and at the end we'll try to grow up as a speaker, events, etc. So about me, my name is Jose Manuel Jurado. I am escalation engineer in SQL Azure, working in Microsoft. Also, subject master expert in this technology in SQL Database, managed instance, and the new databases that we have in as open source and Azure PaaS as MySQL, Progress, and MariaDB. I am a speaker in different events, let's say SQL Saturday, Tech Ready, SQL Nexus, SQL PaaS, and also you have all the contacts about Twitter, LinkedIn, and my email. With me will be my colleague Vito Pombeiro, and unfortunately he is not available right now, so I'm going to deliver the session alone. But for sure that this session also the owner of this session is my colleague Vitor. As you could see, it's also another escalation engineer based in Portugal. I'm based in Spain, as you could notice by my accent, but you have also the details of contact. So what is the reason about this session? Well, it's about three things. First of all, is try to find a performance problem. It's very typical in support. We receive calls from the customer that we want to know what happened, how to find the performance problem. So the idea of this session is try to help you in order to find a performance problem with your application. Second, the idea is try to find what is the query that is taking too much time, because also it's based on real example, because it's a real example working with a customer. I'm going to show you how it's possible to find a query that is taking too much time. And finally, I'm going to show you how to find, after we found the performance problem, the query, what is the bug that we have in this with this code. So let me introduce about the background, about what is the reason that we receive a call that mentioned that my application is running slow, but I don't know why. So let me explain about the background. Right now we receive a call that the customer mentioned that we don't have any updates in the code for a long time. We don't have any new deployment, but it's running very slow. It's an unexpected issue because the customer didn't know what happened without any modification in the production environment. Also, the business was seriously impacted and around 1,000 users impacted. The customer adds a lot of data from the last month without any issues. And finally, if they try to run this process in on-premise, this process took around 20% less in this point. So what is the reason that we have? Okay, so I'm going to stop here. 1 second. Okay, I'm going to show you what is happening. This is the application that our customer has. They mentioned that, okay, I received the call. They show me that what the application, as you could see, the application is running this way. 1 second. They expect that the application is running more faster more than right now is running. Okay, it's running very slow, but they don't know what happened in this point. So in this situation, we need to find what happened in this application. So the first point that that we ask to the customer is try to verify what happened. So as you can see, it's running very slow. The customer didn't know what happened, etc. So let's go to the presentation. So what is the process that we are going to follow up in order to identify the part of the code that is the problem? I would like to suggest, for example, one thing that we are going to show you about a stopwatch is a very useful tool that we have in order to detect what is the time that I spend my functions. We are going to show you how we are going to obtain the connectivity and the execution statistics. And also, we are going to use one thing that is called Visual Studio Profiler, using one part that is called instrumentation, that is possible to know what is the part of the code that is taking too much time. So I'm going back to the application. 1 second here, okay. And the first point is I'm going to suggest to the customer run the profiler, the Visual Studio Profiler. I'm going to click here in the back, choose the performance profiler. I'm going to choose a performance wizard. I'm going to click start. And I'm going to choose one thing that is called instrumentation. I'm going to click here and click next, and click next, and finish. Let's try it right now. Right now, as you could see here, the application is running. We are going to wait a couple of executions, let's say until 20 executions. As you can see, it's taking too much time. Nine, 10, 11. So as you can see, more or less, it's taking around 1 to 2 seconds per executions. Okay, I'm going to stop the profiling. And right now, we have a special report that is using the profiler instrumentation profiling report. As you can see here, the part of the code that is taking too much time is 2 parts. The first is the execution of this command, execute scalar, is taking the 51% of the CPU, let's say the time, let's say. Another one, it's 3D sleep. I'm going to explain what is the reasons. So right now, we know that something happened executing some SQL statement, okay? So I'm going to, okay, customer, we know that the part of the code that is facing this problem, let's try to verify what happened in your code. I'm going to the code. As you can see, this is the process. This is that the customer is using right now the executing scalar, and we have the thread. I'm going to show you one thing that is very important about the stopwatch. As you can see, this is the stopwatch that is this command provide us the way that how much time passed from running this command until we obtain the lapse. So at the end, we could see how much data or how much time we pause in order to execute this query. So other thing that is very important that I'm going to suggest to the customer is to use one thing that is called statistics. You know that the SQL connection that we have in .NET, it's possible to obtain some statistics about, for example, the execution time or the network server time. So when I enable these statistics, and then I'm going to see how much time we took for every execution that we have. Also, as you can see, this customer is running one query, very simple query that select a count, changes the value of this parameter every time that they run the process. So I'm going to enable the application. I'm going to enable the data. 1 second, let me change this value, and I'm going to run again. So right now, you could see that we have more useful information about what happened for every execution that we have. Let me stop here, go back to the application, and explain about the details. So every time that our customer run a select count from the performance, this table from text to search, this value, as you could see, the execution time is around 1,400 milliseconds every time. And also the network server time is 1,400 milliseconds. So also, as you could see, the execution from this part to this part is taking 2 seconds. So what is the reason this is taking 2 seconds? Just only for demonstration, I add this sleep in this process because it's very important to try to distinguish what is the execution of the query or what is the execution of the complete process that you have in the functions. Let me stop here and remove, for example, the thread. And as you could see right now, the execution of the process is more or less, is more or less the same time that we have. We don't have any big difference between the execution of the query and the execution of the stored procedural that we the function that we have here in C#. So that means that the time that I expend in this process is just only execution of the query. Right now, we identify that something happened in the database. Okay, so because as you could see, the time this time is very, very, very similar that we have in this. So let me go to the next to my presentation. So right now, we identify what happened about this about execution. So we identified 3 things: the stopwatch. We use the SQL connectivity execution statistics using the Studio Profiler. So at the end, we found what happened. So what is the next step that we need to do? Is the phase 2. So the idea is to identify the query. What is the tool that we are using in this process? We are going to use the Azure portal in order to identify what is the query that is taking too much time, because it seems, based on the telemetry that we have, or the option that we have, the statistics that we have is taking around 1 or 2 seconds. We are going to review also using the query data store, because it's very important. It's a very useful tool, a very important tool, because with this, we are able to see everything that is happening in my database. Okay, and also we are going to review one thing that is called the execution time, the execution plan. So let's go for the demo. I'm going to use the portal. Okay, I'm going to, 1 second, let me run the process meanwhile. Okay, this process is running. Yeah, the process is running. Okay, go to the portal again. Okay. But the first thing that we need to review is review what happened in my database. As you could see here, when you choose in a portal, you choose your database, you could see one thing that is called this graphic that is computer utilization. But if we click here, we have a lot of metrics that we could find what happened in my database. Right now, I don't know what happened is CPU, IO. I don't know what is the time spent in this point. So for the reason, I'm going to add a new metric in the portal. For example, I'm going to choose CPU. I'm going to choose, for example, that IO. And I'm going to add a new metric that is called log IO. Let me remove this because it's not needed. So something happened in terms of CPU. As you could see here, we don't have high data IO. We don't have high log IO, but it's clear that something happened here about the execution of my CPU. So even one thing that is very important when you are using this type of tools is you could add a new chart. And also, for example, we could review how many connections that we have, because you know that sometimes we could have filet connections, or we could have a lot of new connections. So I'm going to choose this one. Successful connections. And as you can see here, just only we have one connection per time. So if I review what happened, just only in one connection or around 2 connections is causing right now 100% all the time. So I would like to understand that, okay, it's not too much connections. We have a problem in terms of CPU. And also, if we choose, for example, the workers, that is another point that we have. This is very important about the worker percentage. As you could see, it's not too much. So I don't know what happened. So this is the first point that we found right now, that the application is running some SQL statements. This SQL statement is using a lot of CPU. So I'm going to back to the database, and I'm going to review if we have something more about intelligent performance. You know that in SQL Azure, we have the chance to have some options about intelligent performance. For example, performance recommendation. SQL Azure, by default, is analyzing all the requests, all the process, all the workload that you have. And we could provide some information about, okay, you need to create an index, you need to create or delete this index, or doing this way, try to do it this way, or try to verify some details. So you could, if you don't have enabled these things, it's very simple. You need to go to the automatic tuning and enable. Right now it's by default, but you could enable, for example, force plan. You could enable the option to create index. For example, you could specify that if you found something, please create index. And it's something, if the improvement is not that we expect, try to remove the index. So this is the option that we have from Azure that they will create for you. And also drop index. You know that sometimes there is no need to create too much indexes. Sometimes to have a lot of indexes, they are causing a lot of problems in terms of I/O. So for the reason we have this option in automatic tuning. So I'm going to review the performance recommendation, and I don't have any performance recommendation. So I don't know what happened right now. So I'm going to I'm going to go to the queries performance inside, and I'm going to review what happened. As you can see, we have this graphic that contains a lot of information, but it seems that we have something about, as you could see, we have this CPU. You could choose data I/O, you could choose log I/O in terms of the top 5 queries that is using too much CPU. And as you can see here, we have right now a distribution that CPU for the query 348 is not too much, but it seems that we have a query that with the number 632 that is using 70% of the CPU, and also the CPU is 90%. So right now I'm going to click here in the query ID. As you could see right now, we identify the query. So we identify that this query is causing this problem, but I don't know what happened because it's a simple query. It's we run the search from the table from this query. I don't know. So in this case, I'm going to review what is happening. So, for example, let's try to use another tool. For example, as you can see here in SQL Management Studio, we have other way in order to detect the data. For example, if I run select star from sys resource stat, I could see the same metric. Right now, every 15 seconds, I have the utilization in terms of CPU, I/O, etc. So other things that is very important, it's about query store, as I mentioned before. Okay, as I mentioned before, here we have several reports that provide us a lot of information. For example, I'm going to open the query weight statistics. As you can see, the total time in this query is CPU. I'm going to click here. As you could see, we have this time. This is the query that is taking too much time in terms of CPU. You could click here in configure. You could change the data if you want to review what happened this last day, these last 2 days, etc. But right now this is happening. Also, you could see one thing that is called execution plan. So it's very important that right now, as you could see, every time that I run this query, we're running an index scan. So that means that SQL is reading all the data, all the rows that we have in this table, that it seems that we miss most probably an index. Also, you have the information about what is happening, okay? So, for example, other information that we have, you could see the query, or other thing that you could see in the properties. It's a very, very good thing. It's about the parameter list. So this is the parameter that we compile the query. Okay, so you could see here the set options about the environment, the statement, etc. And also we have a warning that is very important about this is the real problem that we have. Okay, so it's very important about other things that you have these cycles. That means that the execution of the query took this time. And also this square means that the execution was canceled. So using also using query data store, we could see when our query was executed correctly, or was canceled. So other things that we have, I'm not going to go more than this, but for example, you know that in query performance inside, we have the chance in order to review the query. In this way, we have also the same operation. If I type here the number of the query, you could see, for example, how much data, for example, here, these executions take this time, was canceled here, was canceled here. So you could see what happened during this time, the execution, and also you could see the plan ID. You know that sometimes we have a regression that you could have different plans for the same executions. Okay, so right now the execution plan means that we have an index scan. So that means that, okay, it seems that this table has not right now an index when I search for this test to search. I'm going to click here. I'm going to this table. Let me stop because it's taking 99% of the CPU. Most probably I'm not able to do a lot of things. 1 second. Let me stop here the application. Okay. Okay. So I'm going to the table is this. This is the query, and this is the index. So as you can see here, we have an index. If I type, for example, the definition of the index, it's taking time. Okay, anyway, it's taking time. Okay. We have the index. We have we are using the field that we are searching the data. So as you could see, test to search, we are using this time, and so we have an index. So I don't know what happened. So we have an index. We have the data. I don't know what happened. Okay. So it seems that or we have a problem with database, or the code is doing something that is strange. Okay, let's try to put more focus about the execution plan. As you can see, we have a warning. Okay, so let me go to the presentation again. Okay, in order to explain with more details about how we found the bug. So what happened in this in this situation? We have an issue, but we don't know what happened. So the background is this query took 1 second per execution. It seems that they are using index scan against index seek. And also how much data you add, this query will take more time. Okay, so I'm going back to the execution and I'm going to review what happened. So as you could see, here we have index scan. That means that for every executions, the number it's SQL is reading 400,000 rows for every executions. They run the aggregate, so they try to calculate how many rows that we have. Okay, and also we have the compute scalar, but we think we have here one thing that is very important. It's about we have an convert implicit. So as you can see here, SQL is converting, it seems that is converting mvarchar to varchar. Okay, because varchar, as you could see here, is varchar, and the parameter of the application is using is mvarchar. As you can see here, if I go back to the properties again, so we have these things. 1 second. Okay, 1 second is here. The parameter list that we are using one thing. It's this. It's this letter means that SQL is using or SQL application is using mvarchar. So let's try to review what happened. I'm going to take the. I'm going to obtain the query and I'm going to run the query. Okay, because I will like what happened. You know that in order to obtain the execution plan, it's very simple. You could click here to obtain the current execution plan. And I'm going to run the query. I'm going to, for example, specify in this case, 1 second, I'm going to copy and paste, what's probably here, parameter, this value. So if I run the query, it's not taking too much time. It's taking 1 second, more or less, is the time that the query running the application is taking for the customer side. And we have the execution here. As you can see, we have index scan. So you know that if the customer is, if the definition of the table right now it's varchar, I'm going to modify it right now this parameter in order to specify varchar instead to use mvarchar. I'm going to do again the same, but removing right now the letter. I'm going to again to use the execution plan. I'm going to execute the query again. So as you can see here, the time spent is 0. Let's say we don't have any warning. And also, if you see the difference between these two executions, is we are using index scan, reading every execution around 400,000 rows, and here we are using index seek that the number of the execution will be just only, or the number of queries will be just only 1. Okay, so in this situation, it's clear that something happened in the code, that it seems that the parameter that this application is using is not the expected parameter value or type that we have for this table. Okay, so in this case, the idea is I'm going to go to applications. I'm going to review what happened in the code. As you can see, it's very important, for example, in SQL Azure, it's very important to use a retry logic. Please remember, before go deeper about it, it's very important about to use a retry logic. You could see that we are using stopwatch. And as you can see here, the application is using the data type and varchar. So I'm going to modify the value. I'm going to modify the parameter to use the right parameter that we have from this table. As you can see, I'm going to use the same varchar with this parameter. So I'm going to modify this and I'm going to run. So as you can see here, right now it's taking a few milliseconds in order to complete the process. As you can see, the difference is very huge. Okay, right now all the executions, it's taking a few milliseconds. For example, remember that previously we have 1 second per every executions. Right now is no more than 36 milliseconds. Also remember that I'm working from in Spain, or I running this application from Spain, so it's taking some time in order to reach not the North Europe region in Azure. So it's going very fast. It's taking it's amazing that about the time that just only modifying the parameters, okay, the data types. So as you can see here, the byte received is 84. The bytes that I sent is to the SQL server, it's 81. I receive 1 row. The execution time is 36, and the network server time, that's mean how much time I'm waiting for a reply from the server, more or less is the same. And also, as you can see, the text is just only without using Unicode or varchar. And also, as you can see here, the execution is taking a few milliseconds in order to complete the process. Okay, so also I'm going to run again the instrumentation about the performance profiler of Visual Studio. Let's wait for a couple of seconds that we have the applications. Okay, let's stop. And also right now, as you could see, right now, all the time it's running this process, okay? The 71% of the time is running the computer scalar that is taking a few milliseconds. So this is that we found this back in this code using this option. So what is the lesson learned that we found that we found in this? Okay, the most important thing is how to use the portal. It's very important to use the portal query store because they will help you when you have any performance problem. So remember that we use the portal. Okay, thanks to the portal, we found what is the query that is taking too much time, because as you could see here, it's taking the CPU. Also, you could see here the CPU time that for every hour that took the percentage. For example, 70% of the CPU during this time was executed around 1,700 operations per time. You could see the recommendations. Remember that it's very important that SQL, we analyze the workload and provide indexes. As you could see, we don't have any problems with the indexes because we have this index created, okay. And also in the performance inside, we didn't see any. We saw the query that is taking this process, the execution, etc. So it's very important to use the portal. Also, it's very important about to use the query store, because using the query store, as you can see, we have the way to analyze all the data in a very best way in order to find multiple things about not just only this time about it. For example, other things that I would like to share with you before go to another point. It's also, you could see in the top resource consuming queries, you could see, for example, how much time, the duration of the query, or how much time in terms of CPU, run count, logical writes, logical reads, and also you could see in terms of average, in terms of max, mean values, etc. And one thing that it's very important, if you don't need to use the graphics, also you could see the data just only with the query, the time that that we have. Okay, so it's in this grid, you have the chance to review all the queries, what happened with these queries. Every time that I click in the query, you are going to receive the query, you are going to see the client ID, etc. So it's very important. Use this one. Other things that I will like in terms of executions, I would like to show you one thing that also is very important about the alerts and diagnostic settings. You know that other things that you could, beside the query store and the portal, is to use, for example, diagnostic settings. So what does mean, diagnostic settings? Another way to monitor all the queries, you could send all the information that we have about query store runtime statistics, weight statistics, errors that you have in your database weight statistics, timeout, blocks, deadlocks, etc. You could send this information to one thing that is called Log Analytics Workspace. So if I open this Log Analytics Workspace, example here, we have another way in order to detect the data, to detect what happened with my database. For example, here, you could see that other report that we have is, okay, this database is taking the 90% of the CPU. You have several reports about the query duration in seconds, the number of errors that we have. We don't have any deadlocks, we don't have any timeouts, we don't have any blockings. So at the end, that means that it's just only a pure execution. So if I click here, as you could see, you have more information about, okay, this query is taking this time. This is the weight stat that you have. This is the query, the query ID that you have, and also report all the information that we have here. If you, for example, if you want to have more data or you want to create your personal reports, I'm going to show you right now. But also, as you can see here, you have a lot of our reports in order to monitor your database without using any third-party tool. Just only enable the log diagnostic settings, or this option, you are going to have multiple things. If you want to review the data by yourself, one thing that we could use is, for example, show you. 1 second, I don't know what happened. Yeah. It's about the query to retrieve the data directly from the tables that we are using in order to obtain the data. So right now, when you enable the diagnostic settings, all the information that we have, it's going to this table. This is one query. This is let's say the syntax or the syntax or the query. It's using Custo. You could find Custo, the documentation about how to query the data using, for example, Pluralsight. You have this information about it. But right now, as you could see here, for example, this query is to obtain how much time in terms of execution took my query. So as you could see, you could query Azure Diagnostics. You could retrieve about the category query store runtime statistics about my resources ID. Was this my subscription, the server, etc. You could see all the information that you need. Also, if I want, for example, instead to have a metric every, for example, every 30 minutes, we could modify it, for example, for every 5 minutes. So if I run the query, I'm going to have more information in intervals about every 5 minutes. So it's a very important to know this, because using this option, you could have a lot of information about it. So let me go back to the presentation again. And also about you, other things. The most important thing, we found the bug. We found that please review your code, okay? Because as you could see, using a parameter that is using varchar and the table is varchar, yes, the time is not too much. It's just only 1 second. But if you run this operation multiple times, at the end, the process will take too much time.
I want to interrupt and let you know
yes.
that we are at 40 minutes past, and there are no posted questions, but you have 5 minutes.
Okay. Just only I'm going to finish because this is the last slide. As I mentioned, test in advance. You query, try to, if your table will grow, test it. Also, one thing that is very important, it's not always the bigger database tier helps, because in this case, we could increase the database tier for more powerful, and you are going to have the same problem. For my recommendation, if you want to save your money, invest your time in diagnostic and coding. I think that is very important. If you code, your source code is good, and you review the code and you tune in the code, most probably you are going to save your money, and you are going to have a very good performance. Finally, all the information that you could see, it's you could click here in GitHub in order to obtain how to monitor the code, as I mentioned, using PowerShell. And again, provide your code. Okay, it's very important, because we start thinking that the problem is the database, and the end was the application. So right now it's time for questions. This is the table of contacts, so I'm waiting for if you have any questions.
You know that we want to post our questions in the chat window so that we can get them to Jose, but there are no posted right now.
It seems that we don't have too many questions, right?
I think it was very clear. There was a lot of information. You delivered it very well.
Thank you so much.
So people will probably reach out to you when they have time to digest all of this information and try to use this. Then they'll be calling you and say, wait a minute, tell me again.
Okay.
But this is terrific. Thank you so much for your time and effort and energy putting this together.
Thank you so much for giving this opportunity. I'm very happy and excited to stay here. Thank you so much.
It's a terrific event. Thank you.
Yeah, thank you so much.